طبعا دراستنا البحث هو عن الأنقاض، يعني استخدام الأنقاض اللي موجودة في العراق واليمن وسوريا. Studying the properties of the debris and their using paving layer of roads and concrete construction. The rapid population growth has led to increase the infrastructure, which led to increase the demand of aggregate. And you know the percentage of aggregate in all world reached more than 48 billion metric ton. In this study, we are studied all the debris of demolition waste subbase. It does mean column, concrete slab, brick walls and rock walls, foundation, gypsum, and concrete block and soil. يعني بصورة عامة أنه أنا درست الأنقاض اللي موجودة المهدمة من المنازل والمنشآت اللي صارت أثناء الحروب في العراق، فاستخدمتها توتالي كلها، سويت لها كراشنج وبدينا أشتغلها كمواد حصى خابط للسبيس اللي هي تحت البيفمنت. الكيس ستدي عندنا أنبار province with population of 2 million. There are 3 regions are destroyed in Anbar: middle region, east region, west region. In this research, I studied all the debris. Studied only the debris of Ramadi city, not in middle and east. Only Ramadi city, the center of Anbar, and it was the quantity of the debris in Ramadi city more than 12 million cubic meters. طبعا هاي ملاحظة مهمة جدا، يعني احنا نحكي على الأنقاض فراح أحكي عربي إنجليزي. يعني هسه إذا يقول لك الأنقاض احنا سنسويها يعني disposal the debris، يعني خارج المدينة، يعني إذا راح نحتاج إلى كلفة نقل لطرح هاي الأنقاض. فبعد سنوات، خلينا نقول 3 سنوات 4 سنوات بعد يعني تطوير المنطقة، راح نحتاج نضطر إلى كلفة نقل أخرى ثانية، فلذلك لازم نتعامل معها الأنقاض ونستخدمها حاليا يعني بالوقت الحاضر، فنقلل التلوث وبالتالي احنا استفادين منها في أعمال الهندسة المدنية. فممكن نسمي هاي يعني نسمي هاي الكلف بكلف مستقبلية، كلف نقل مستقبلية. طبعا 80% of Ramadi city has destroyed completely, and this image show the destroyed. Here also steps of building demolition. First of all, remove all the war waste by other companies. Second, destroyed the building by machine to separate the steel bar from the concrete to use it again. And here this photo also. 3, readjustment the steel bar for use it also in the building. Here upload the debris inside the trucks to the landfills. Actually, we have 2 landfills in Anbar in our province. One is name is Salah landfill, and second is Hafriya landfill with these dimensions. And you can see from this photo, all the debris, it's good for subbase layer, for pavement. It is concrete block, it's raw material. And this photo also show the locations of landfills. Process of taking samples. Actually, 30 samples were taken randomly every 25 meters by shovel machine from Salah landfill, and the total quantity of the samples were 40 cubic meters. And these samples were crushed in a small crusher located near of Anbar University. Actually, the 40 meter cubic was crushed within 2 hours only with a small crusher. And the maximum size of aggregate was 75 millim. And maybe you ask me, where's the wood and the plastic material? Actually, the plastic material and wood, it's thrown away because there is a sieve inside the factory or inside the crusher. The cost of crushing per cubic meter was 1.25 US dollar. It's cheaper than the price of the natural subbase or natural material from quarries, from our quarries in Iraq. It is 1.67 US dollar. And this photo shows how to take the materials inside the hooper. This is the debris inside the hooper in the crusher. Here on the belt, you can see the sieve. This sieve to separate the organic material like wood, plastic material, and we get only the raw material to use it in the pavement, such as base layer or sub-base layer. Here video I want to show you this debris inside the belt.
سيد صلاح هذا الفيديو قد ايه مدته؟
Only
ما
30 seconds
ضروري
only.
اوكي
Okay, this is crusher for the materials. You can see the output of the material. Test the debris material. First of all is a chemical test such as SO3, sulfate content, gypsum content, and total soluble salt test, TSS. This is for chemical test. Other sieve analysis test, compaction test, CBR value, resonant modulus, and the effect of radiation is none according to the UNIB studies. And this table show the chemical test. You can see from this table as the average for SO3 and TSS and gypsum content is within the range 1.22, 5.5, 2.61 is less than the specification of the road and construction. And this table shows the sieve analysis. From this table, you can see our material, the percentage of passing from first column within class A. This is Iraqi specification class A. It does mean the class A for road construction. This debris material as comparing with the natural subbase or natural material. Also, other test, this is a proportion of the material. I use this table to check how much quantity of the percentage of concrete and gravel, how much percentage of brick, percentage of rock, percentage of gypsum, ceramic, percentage of asphalt, concrete, percentage of fine material, percentage of glass, wood, and plastic material. Actually, the important columns or important material from this table is the percentage of concrete and gravel. Also, the percentage of fine material. From this table, you can use the material as base or sub-base material in the pavement layer. And the construction test section, I took 6 by 6 meter, okay, laying the debris. This is debris material. You can see from these photos, this is debris material. I use this material with thickness 20 centimeters and spraying with water and compaction the material by steel roller. After that, you can see the photo on the right. After spraying the water and compact the road, I took 5 samples for compaction test. And this photo shows how to take the samples for compaction test. The result for the test. 5 samples were taken to calculate the compaction test. The maximum dry density was 20.35 kilogram per cubic meter, and the optimum moisture content was 8%. The average percentage of compaction, it was 95.9. It is good as comparing with the natural subbase. 95.98%. And CBR value also 37, according to the general specification of road and the bridge in Iraq. Result modulus also was 377.7 megapascal. Workshops. Actually, it was 3 workshops in Iraq. One in Mosul University by UNIB and UN Hepatite. Second in Anbar University with UNIB and UNDP and UNIB also. And 3 in Kirkuk University by UNIB and UNAMI. Actually, the result from the workshops, it was 3 governments. My study, it was 3 governments: Anbar, Kirkuk, Mosul. In Anbar, it was the quantity of debris 12 million cubic meters. The cost of recycling $1.25 US, as comparing with the cost of natural material $3.3 US. Okay. In Jaraishi also, we have in Anbar we have 2 quarries, Garma and Jaraishi. In Garma $3.3 US, the natural subbase, and in Jaraishi 1.67. In Kirkuk also the cost of recycling only $1.25 US, but in Kirkuk quarries the natural material 1.67. Also in Mosul same thing, 1.25 the cost of crushing, and as comparing with the cost of natural material 1.67. It does mean the crushing of material or the crushing of the debris material is cheaper than the buying of the material. The result of workshop, it was 1 crusher was purchased by IOM and UNIB to the municipality of Mosul, and the production of this machine, it was 80 tons per day, and the price of each crusher about $70,000 US. Conclusion: the chemical test and all the tests in the material, in the debris materials, was within the range. I mean that with the range of the test of the road, as comparing with the material, the natural material. Also, the recommendation, we recommendation that installing the crusher inside the Al Sara landfill, because it is considered the biggest place to dispose the debris material, with dimension of 3,000 meters length and width of 300 meters, and the depth is varying from 7 to 9 meters. Using the material, using the debris material as base or sub-base layer in the construction of roads. Also using the aggregate of debris materials to manufacture the concrete block pavement, interlock, and also in manufacture curb stone for the pavement. And this photo with Mr. Martin in Ramadi city. He is also the manager of UNIP in Ramadi. Thank you.